Section 6.6, Geometric Sequences. So, here's a little suggestion for you. Why don't you go home tonight, see if your parents will accept the following deal. You will do all household chores, laundry, dishes, taking out the trash, raking the leaves, etc. for a small fee as long as you get a consistent raise. Alright, so all of these different chores down here, you'll do them all for a very modest price. Start off the entire first month. You're only going to charge them 1 cent. 1 cent, that's it. But we need a little bit of a raise, so the second month we're going to go up to 2 cents. Very small raise there. And now, to get those 2 cents, we're not just getting an extra cent, we're doubling our original salary. So my first month's salary was 1 cent, second month, 2 cents, third month, 4 cents, fourth month, 8 cents. And so on, and this will continue. Now, you might be thinking, this doesn't seem like a very good deal for you. You're not really interested in doing it this way. Well, let's take a look and see what happens as this keeps on going. So, first of all, I'd like to know what your monthly salary would be after 1 year. If you're starting at 1 cent, and then you're just going to double it to 2 cents, to 4 cents, to 8 cents, to 16 cents, and so on, I want to do that after a full 12 months and see what our monthly salary would be. So let's take a look here. So if you had started in January, let's say, then you'd be making 1 cent in January, 2 cents in February. You can see what happens. We go through March, April, May, June, July, August, September, October, November, and December. So after this first year, our final monthly salary is still only $20.50 just about, which is not a lot considering all the work that we've done around the house for a full month. But it did start to grow pretty quickly. Well, without showing everything in between, what would happen after 2 years? Try to figure it out and then check your work. Did you get it? After 2 years, in that second December after starting this deal, your monthly salary will be $83,886.08. That's a pretty good amount to be starting with, or to end up with after 2 years. What if you were able to keep this going for another year? Using that as a starting point, find out what would happen at the end of the next year, then come back and check your work. Did you get this one? If you were somehow able to convince your parents that you should be able to keep this going after 3 years, in that third December, your monthly salary would be $687,194,767.36. Even Ron Burgundy would agree that escalated quickly. So what we've been looking at here is something called a geometric sequence. This is related to when we did arithmetic sequences before, which had common differences. Geometric sequences have common ratios. With arithmetic sequences, you add or subtract to get to the next term. With geometric sequences, you multiply or divide by the same number over and over again. This number is called a common ratio. So in this particular example, we were looking at an a sub 1, which is our starting point of 1 cent. So I would write that as 0.01. Our common ratio is what we're multiplying by to get to the next term. So in this case, we were doubling it, so our common ratio is 2. So now in order to write our formula, we'd be using a sub n, which is the nth term, equals 0.01. That's times r is 2 to the n minus 1. You'll see that's very similar to the common difference and a sub 1 term that we used in an arithmetic sequence. So what we did here, for example, is we used, if we wanted to figure out what our salary would be after 8 months, wanted to figure out a sub 8, we would just say 0.01 times 2 to the 8 minus 1. And in your exponent there, you're going to do 8 minus 1 is 7. And then we could either figure out or somehow do the math to realize that 2 to the 7th is 128. And then when we do the multiplication, we get that the 8th month salary, which would be the salary in August from the previous page, would be $1.28. And so that really is all you pretty much need to know about geometric sequences. And so in order to figure out the 2 and 3 year totals, I just used this with 24 and 36 for the value of n. But there you go. I hope that this makes sense, and now that you feel comfortable using geometric sequences.